members to welcome you for this session. Thank you so much for joining. This is a continuation from where we ended yesterday. Yesterday we had our first lesson, and our lesson yesterday was about coding in agriculture, the importance of coding, what is coding. That's what we were able to look at, and also we are able to look at which kind of problems or which kind of challenges can be solved using the knowledge of coding. So Professor took us through that session that was about the knowledge in coding, and he was very clear. He told us that coding is used in everything that we do in life, and therefore it means that you may not be someone within the agricultural field, but you need the knowledge of coding. The professor also was able to tell us and that when they talk about coding, for those who are not here, that coding means a procedure or a formula for solving a problem based on carrying out a sequence of specified actions. So he gave us numerous definitions of what coding is. He told us it can also be a procedure for optimizing resources in achieving a given goal. He also told us that it can be a simple cookbook recipe, a prescribed bureaucratic procedure, or a computer program that stops. So that is what we looked at briefly. And then he was able to take us through which questions are answered when you do the coding. He told us that through coding, you can be able to answer questions such as, how can technology be used to improve agriculture? So in case you are not an agriculture teacher, or you are not someone who is doing agriculture, then where there is agriculture, substitute your subject, that how can technology be used to improve mathematics, to improve physics, to improve biology, to improve my daily life. So that's what we were able to look at yesterday. So we went on and looked at the basics of what in coding. We looked at the benefits of coding, and more so when it comes to agriculture. And we said that it enables farmers to leverage technology and data to optimize various processes. And also, Professor was able to tell us that it can help, one, to improve on the efficiency and also in decision making when it comes to agriculture. So that was briefly about what we looked at when it came to yesterday's lesson that was focusing on the aspect of knowledge. So that's where we ended yesterday. And today, Professor is going to be building up from that point to take us into another lesson. So allow me now to welcome Professor to take us through today's session. Professor, you're most welcome.
Thank you, Stephen, for that review of yesterday's lesson, which is very interesting. So today I'm going to share with the class the lesson on understanding the basic concepts of coding. So for now, I'm sharing with you the PowerPoint which we are going to use. I hope each and every one of you can be able to see it. So, it should read lesson 2, understanding basic concepts of coding in agriculture. The outline of the presentation today will be an introduction to the subject, then also looking at the 3 stages of problem solving. So we shall be trying to understand the basic concepts of the problem solving approach by looking at the 3 stages of capturing data, processing data, and providing solutions. It's more like we cook food on 3 stones. The algorithm also transcends the 3 stages of the process of solving a problem. Then for each of those stages, we shall look at the principles and practices that are used in coding. Then we shall have acknowledgements. The introduction. In order to maximize benefits from coding in agriculture, it is important to understand the basic concepts pertaining to problem-solving process, which consists of 3 stages. The first stage is capturing data. The second stage is processing data. And the third stage is providing a solution. So, understanding which encapsulates discernment, that means like building on the knowledge yesterday, one must be able to discern the difference between coding and programming. We realized that coding is a subset. Then comprehension is more of the deeper understanding, which we want to build today. And once you have been baptized in the deep understanding, you can make interpretations and know this is true, this is false, this is the direction I have to take, and you can make decisions. So understanding is a critical thing. Without understanding, you can never put to action something very well. So this particular lesson is designed for understanding to inform the design of robust algorithms that effectively address the problem at hand. The hypothesis here is that if we are to develop effective, efficient algorithms that address a problem, then we must have thorough understanding of the different concepts that pertain to the problem we are looking at and informing the algorithm that we developed, which we call the step-by-step coding. So we look at the first stage of problem-solving process, which is capturing data. So some of the concepts include input data requirements. Close attention must be paid to it for the algorithm. In terms of the nature of algorithm that you are going to write, the format, the data sources, quality, even the data structures. The one thing I want our class to learn is that when you are thinking about the data to be captured, it must be related to the problem you are addressing, but also must match the goal which you intend to score. So you don't just collect data for an algorithm or develop an algorithm without paying attention to the goal. In a way, we start from the goal post and we work backwards. That concept must be honed down. Then the other thing, as I mentioned yesterday, are collecting data, especially big data that are required for effective algorithm. It's costly, so you must integrate existing secondary data as much as possible. You must mine all the data that is available before thinking about collecting new primary data, which is very costly. But once you have accumulated the existing data and you identify the gaps, then you can work towards identifying primary data. For technology, we use sensors for the different variables. Like yesterday, I mentioned moisture content in the soil, temperature in the atmosphere, it is relative humidity. And these can be captured using microcontrollers such as Arduino and Raspberry sensor data continuum. Some of these are the things for those who will go for the diploma and higher classes. This is what we will be covering in details. The sensors that are used to capture the data. But the point here is that You begin with the secondary data which other people have already collected, and then you target to invest in sensors to collect the relevant data that is missing. Once you have the data, it's important to validate it to ensure that whatever is captured is valid, accurate, complete, and this is done by performing checks and validation to rid it of the errors and inconsistencies. As you all know, garbage in, garbage out. So we must make sure that the quality of data that we are going to input into our algorithm is accurate, it is precise, it is complete, and will be able to help us address the problem at hand. Then another concept is the data representation. You must determine the most suitable way to package the captured data for further processing by choosing suitable data structures, formats, and encoding schemes, again, matching the goal. So that is another concept. Data must be packaged in a form that the processor or your technology is going to effectively use it. It must be compliant. And so particular attention must be paid to that, and it must be clearly understood if you are going to input the right data to be processed in order to have the right solution. We now move on to the second stage once we have collected the data. And the second stage of problem-solving process is processing the data. This one consists of developing and using a programming algorithm. Then it has the rules, which we call syntax. Then it has the functions, which are able to perform and get solutions to the problems we have. And then there are operators which work like sensors to provide direction to make decision. We must have clear understanding of the algorithm and the logic that is used. The important point here to understand is that the algorithm must be efficient and effective. For it to be efficient and effective, if you are going to develop it as a coding student, you must have very good understanding of the underlying concepts behind an algorithm and its efficiency to inform the choice and logical processes to analyze the captured data. I must say that an algorithm is the foundation of coding, and it helps to generate efficient solutions. An algorithm is a step-by-step set of instructions structured for solving a specific problem. Some of you may be familiar with the flow charts. Many people, when they are constructing or they are mapping out an algorithm, they begin by making a flow chart. In our case, if we are to construct a flow chart, we have begun with the data capture. Now we are in processing data. Then the flow chart would end with providing a solution. But a flow chart is a simple way of organizing your thoughts when you are preparing to write down a software solution or an algorithm, essentially what we call coding. Another aspect that we need to understand is modularization. As you know, if you are addressing a complex problem, it is always good for the mind to break it into sub-problems. So that's the concept of modularization. In other classes, they say the course is modular, meaning it consists of modules, small learning content that are presented to the learners. So that's a concept we need to hammer down. Whenever we have a complex problem, we must be able to break it down in order to be able to be effective and efficient. It is characterized by sequencing, iteration, which we call loops, and conditional statement, if else, to guide decisions. Still in stage 2 of processing data, there are rules of the game. There are rules that govern the algorithm, and this must be understood. So syntax refers to the rules and structure that define how a code is written in a programming language such as Python. Syntax is specific to a programming language, so you cannot just master the rules in Python and you think they can work in another language, maybe C+ or another language. So syntax governs the order and format of statements, declarations, and expressions in a code. Syntax errors occur when the code violates the rules of the programming language. So as students of coding, you must pay attention to the rules or the syntax. When you reflect, like on the Bible, when God was coding us, he gave Moses the 10 Commandments, gave him ordinances, statutes, and all of those to govern our lives. So in the same way, if we expect a computer to process our algorithm, we must give it rules. Now we come to functions. Functions are blocks of reusable code that perform a specific task. Earlier, I mentioned about modularization and breaking down a complex problem into small sub-problems. And so a function is the algorithm that is used to solve a small sub-problem. And it can be reused for another one where it is applicable in order to be able to run the entire algorithm to produce the solution. So what is a function? A function comprises of a series of instructions that enables execution of the code multiple times. Functions have parameters, inputs like X, and then they return the outputs like Y from commands such as print. So functions are very useful in algorithms in coding. Functions reduce costs by promoting code reusability, modularity, and readability. You can be able to use them, reuse them. You can be able to apply them for the different modules, and they are easily readable. Next, we go to operators. Operators are symbols or keywords that perform computational operations on operands, variables, values, or expressions, useful for making decisions in a code. They can be arithmetical, like 1 plus 1. So you have a variable 1, then you have an arithmetic operator as plus. It can be a minus, it can be multiplication, it can be division, it can be a percentage, and they perform mathematical calculations. So as a student of coding, you must understand where to place an arithmetic operator And then there are also other operators for comparison, such as greater than, or equal, or less. And these compare values and they return the Boolean results true or false. So when you run a function and you put an operator, if this is greater than x, then it is true. Or if this is less than x, then it is false. So those operators must be very well understood if you are to write efficient and effective algorithms. Then there are logical operators such as and or not, which are used to combine and manipulate Boolean variables. There are also assignment operators like equal, plus, which are used to assign values to variables. Again, by my background, being a teacher, I always want to simplify these things because we are trying to create like God created. If you reflect on these operators, they are like the senses. We have the sense of taste, we have the sense of smell, sense of touch, sense of hearing. These are the ones that can help you in your operations to make a decision whether you move away because there is a smell, or you can eat the food because it tastes as you like. In a way, you must, as a student of coding, appreciate these operators like we have God appreciates, or we ourselves appreciate our senses of touch, of hearing, of smell, and all of that. Now we go to another important stage, concepts of transformation of data. Data transformation is an important concept that must be clearly understood because this process may be necessary to extract meaningful information and derive insights, and is done by specific calculations or operations using various computational techniques and methods. For example, when we are going to do soil testing in the field, we choose the sampling units based on the cover that is there. For example, what type of vegetation is there. And if we have sensors or cameras which may be mounted on drones and all of that, and we take a picture, what comes out is a picture, images of different frequencies and wavelengths showing differences in colors. But that information must be transformed in order to know that in this section, the vegetation is different. Here there's grass, or here trees, so that if we are sampling an area where there are shrubs or grasses, we sample different units. So the data that you have must be transformed. That's an important concept that must be understood. Basically here I'm trying to highlight the simple concepts, but as you grow in your studentship as coders, these concepts you will be able to scrutinize deeply and critically to be able to apply them to solve your problems. Then there is optimization concept of the data, processing steps, which is important to improve efficiency, reduce computational complexity, and enhance overall performance by using several techniques such as caching, parallel processing, algorithmic improvements. In a way, like we cook food and we season it, the data must be processed because all you know, we are trying to make technology help us, but we must also help technology by providing data in structures, forms, and formats that will reduce its computational complexity so that it can be able to do the computations we want easily. So optimization of data is an important activity in the step of processing data. Then once you have transformed your data and it is optimized, you've input it in your processor, we go to what we call data analytics and decisional making. This is the mathematical and statistical concepts that are used in data management in order to get a solution when you are solving a problem. There are so many of those: regression analysis, there are those of squaring, there are so many mathematical concepts that and statistical concepts that can be used: arithmetic, geometric, graphical, and all of those that can be used by technology in order to solve a given problem. There are also other concepts that as students of coding, you must understand in the stage of processing data, like big data, data mining, and predictive analytics. Big data. These are extremely large data sets that may be analyzed using a computer to reveal patterns, trends, and associations relating human behavior and interactions. But in agriculture, we may be trying to understand yields, crop yields, or livestock yields. So a lot of data can be used. A lot of data may come from soils, and soils vary from soil, from place to place, location to location, in terms of steepness, in terms of length of steepness, depth of the soil layer, moisture content in the soil, nutrient content. Then you also have the plant characteristics. Some crops may be fast growing, they may be resilient, others may not. So you have to capture that data. Then even in the atmosphere, you have the rainfall, you have the relative humidity, temperature. That's what we call big data sets in order to be able to understand our yield is affected. So these are extremely large data sets in the atmosphere, in the plant, and in the soils. So you have climate data, soils data, crop data, and these must be analyzed in order to predict the yield that you expect. Data mining is a practice of analyzing those large databases in order to generate new information. So we process the data using computers, automation to search large sets of data for patterns and trends, turning those findings into business insights and predictions, as I've mentioned, such as yield. The word mining is here, like we say gold mining, you are mining iron, and all of that. In the same way, it's the practice of mining the data, meaning getting wealth out of the data in terms of the patterns and trends to inform your projections and predictions. So it includes assessments of relationships between parameters X and Y, such as product and customer age, gender, tests, and all of that. So you can be able to build your career as a data miner. Then we come to predictive analytics. This is the practice of using data, statistical algorithms, machine learning techniques to extract meaningful patterns and trends from data and using them to generate a prediction of future events or outcomes. So in coding, many people use predictive analytics, but I can say it is a subset of data mining, which looks at the art or science of deriving meaningful patterns and trends for the future. That's why I call it predictive. Now, learners or students, we have been looking at so far the first stage of problem solving, data capture. We have also looked at second stage of problem solving process, which is processing the data. We now come to the third stage, which is providing a solution. So the concepts that we look at mainly here are three: output generation or the solution format. And this is determined based on the problem requirements, where you define the structure, presentation to make it meaningful and useful to the end users. So the output generation, when you are developing an algorithm, you must make sure that you pay particular attention to the solution that you are going to develop. Then result evaluation. This is important and it is done by assessing the quality and validity of the generated solution to verify if it meets the desired objectives and aligns with the expected outcomes. So when you develop an algorithm, please make sure that you are able to evaluate the quality and validity of the results. You don't market your code without validating it. Then another concept is iteration and refinement. This is done when the solution is not satisfactory by process iteration, capture new data, refining the processing steps, and generating alternative solutions until the desirable outcome is achieved. So when you write that is satisfactory, if it is not, then you have to refine the steps, maybe by inputting new data and then generating alternative solutions until the desirable outcome is achieved. There is a local saying that he who continues or perseveres, he who continues persevering in eating the food is the one who eventually derives satisfaction. So it's not a one-time off, it is an iterative process. The Baganda say, adingane golu yali jamuchi omukuto. So even the code, there are some people, for example, who fly the drone, but it can fly, but when it is landing, it just falls down and breaks, meaning they have not hammered down that final step. So it requires looking at that code, that particular section, and ensure that the desirable outcome comes. So all these processes are important, concepts are important if we are going to develop an effective and efficient algorithm. So since we have completed the three stages of the problem-oriented solving algorithm, we now need to have some bit of understanding of the principles and practices of algorithms. So understanding the underlying principles behind an algorithm and its efficiency can inform the choice and logical processes to analyze the captured data. Basically, it means if you are going to develop a good code or algorithm, you must be able to understand principles behind that algorithm that govern the data that you intend to capture in order to solve a problem. So, some of the concepts or principles that we have is an algorithm which is called greedy algorithm. When this algorithm is written, it is written in order to optimize problems to get optimal solutions by extracting the maximum in minimum time or using minimum resources. For example, in soil testing, when we are selecting soil sampling units in a way that optimizes a specific criteria, we use vegetation. We can be able to see which sampling units have different types of vegetation, and then we are able to optimize the number of samples, because as I mentioned, the more samples you have, the more costly it is. So we want to minimize resources by having a minimum number of samples taken. So here you may consider using a grid algorithm. And the way this one is done is that you order the list of resources in terms of profit, cost, value, and then you look at the maximum of all the resources, maximum profit, maximum value, and all of that. So like, for example, if we want to take the minimum number of soil samples, there are many parameters that one has to look at: soil color, the stoniness of the soil, the slope, and all of that. But for grid algorithm, we may use one compounding parameter like the vegetation, because the vegetation is able to sense or to capture the dimensions of the different soil properties, or the soil colors, nutrient status, moisture, and all of those, they are taken care of. The next one is the dynamic programming algorithm. This one works by remembering and building on results of a previous run and using them to arrive at new results. It solves complex problems by breaking them up into multiple sub-problems, solving them one by one, and storing them in future reference and use. It can be used to determine the optimal combination of soil samples from different subplots to minimize the cost of analysis. But for some of you who have mobile phones, like I believe many do, the mobile phone, when you are looking out for a name, say Stephen Kaziba in the phone book, in the contact address book, it kind of works by remembering the others and then puts them aside until it arrives at the specific name. That's what we call dynamic programming algorithms. So these concepts and principles will inform your practice, but you must be able to understand exactly how you want to address your problem, or what problem you want to address, then what sources of data you have. So it's dynamic programming problem. The other one is what they call divide and conquer algorithm. It is structured with the first part. The problem is broken into small sub-problems of the same time, while the second part is where the small problems are solved and solutions considered together to come up with the final solution to the problem. In a way, this principle recognizes complexity, but that you have to subdivide. Like earlier, we were looking at the concept of modulation and all of this. These same concepts apply across all the three stages of our process of problem solving. For soil testing, the field is divided into distinct sampling units with different characteristics, which are then divided into sub-regions for which samples are analyzed independently and the results are combined to give recommendation for the entire field. So these principles are applicable in real life, in soil testing, and in many other problems that we solve. Another category of algorithm is recursive. This solves problems by breaking them down into smaller instances of the same problem and entails repetition of steps till the problem is solved. It can be used to systematically collect soil samples from subplots within subplots, starting at the highest level of subdivision down the smallest subplots. The fifth one is brute force. As the name sounds, this is brutal. It involves blind iteration of solving problems systematically, trying all possible solutions without breaking them down until it arrives at one or more solutions. So this one is a little bit blind and all of that. It is used to exhaustively search and evaluate all possible combinations of soil sampling locations to find a combination that yields the best overall results. So this one captures all the data, like you mentioned. When we are selecting a soil sampling unit, we use the simplest parameter that captures all the others, that's vegetation. But this one can look at data, big data on the soil color, on nutrient status, moisture, then it comes to vegetation. So as a way of solving the problem, our problem is to identify minimum number of sampling units. This one captures all the data rather than subdividing like we do. So those are some of the examples that we can use and see that we need to understand the principles behind each algorithms by understanding the nature of the problem we are addressing. The last one is backtracking algorithm. It entails finding a solution in an incremental manner by making choices from the solution space and exploring them if they lead to a dead end, undoing the choices and trying alternative options. It kind of runs to and fro. It's useful in a situation where there are constraints or limitations to consider during soil sampling process. For example, if we have identified the different units, maybe 2 sampling units in an acre, where there is grass and shrubs. Those 2 sampling units will be sampled separately. But what this backtracking does then, within each of those sampling units, it looks at the anthills, the trees, roads, and avoids those going to and fro until we identify where to take the soil samples. I think that marks the end of our concepts, understanding the basic concepts of coding. So basically, these are all the concepts that we need to understand. But as you realize, each one of them is deep, and you must understand all of them in order to be able to get the best principles and practices when you are developing your code, which feed into the first stage of problem solving process, that is capturing the data, processing the data, and providing the solution. So this must be understood, and this brings us to the conclusion of understanding the basic concepts in coding. And so I wish to end by once again thanking the Commonwealth of Learning, Government of Uganda through its body, National Council of Higher Education, Local Government of Wakiso District, Board of Directors, Light, Open and Blended University Lobu, members of Lobu University Council, members of Truth Bible Church TBC, Mr. Ronald Dungu and Mr. Stephen Kaziba. Thank you. I submit to Stephen Kaziba.
Thank you very much, Professor, for the wonderful presentation. We are really very grateful, and let me hope everyone here, at least you have picked something from the presentation. This is the second lesson, but before we say anything, in case you have any questions, in case there is anything you may want the professor to clarify on, kindly raise up your hand, or you can have your question put in the chat. In case there is any question you want the professor maybe to talk about, anything that you want the professor maybe, kindly feel free to ask now. Those who may have some questions, this is the time that you can now ask. Okay. I think members have been able to understand. This is the second lesson, and we are going to be able to upload this lesson onto the YouTube, but also in the Google Classroom. Those who have not yet received the notes for yesterday's lesson, kindly check on the Google Classroom. Those lessons have been, the notes have been uploaded on the Google Classroom, and today's slides are also going to be uploaded onto the same platform. So just join that platform to be able to access any information that you may want about the lessons. We are going to continue to use the same links up to next week, where we shall have our face-to-face session. So kindly at exactly 2 always just use this link to join such that we can start on time. So please keep time for tomorrow's session. Tomorrow we shall be going in for lesson 3. So kindly keep time. And in case you have any questions, kindly be open to ask. Okay. Yes, Matthew, unmute and ask. Matthew?
Yes, good afternoon.
Yes, good afternoon.
I think I need a detailed explanation on the algorithms. I've really not understood the first part.
Okay. Professor, maybe you can break for him a bit on what an algorithm is.
Okay. So, an algorithm is basically a step-by-step instruction that you use to inform technology to be able to solve your problem at hand. Step-by-step instructions. So you can write down, and that's what we call a code. It's the one that powers your gadgets. It's the one that powers the computer to be able to solve a problem. I've given, for example, the example of selecting the name Stephen from the phone books or address book. So the computer must have a language. It must have communication, which informs it or instructs it to execute a kind of software solution to address a problem. So it is written down, it's codified. It's the same as we said cookbook, just like you have for a human being. If you have your daughter, she has maybe just completed S6 in Gaza High School, and you want her to make cake, and you write down that you get flour, then you get this volume of water, you add this, then you mix, all of that. That's kind of the step. So just like a parent can do to a daughter, God does to human beings, what we are trying to do here is to give instructions to maybe a mobile phone, a computer, a gadget, so that it can be able to run. That's basically what it is.
Wow. Thank you so
Does
much.
that help?
Yes, thank you so
Matthew?
much, Prophet. I've understood. Thank you.
Great. Thank you so much, Professor. Any other question, dear members? Anyone who may have a question? Okay, I think it is okay. Now, tomorrow we shall be dealing with lesson 3, and lesson 3 is the lesson for wisdom. So that is the lesson 3, which is wisdom. And tomorrow we shall have what we call now coding level 1. So tomorrow, do not miss. But as you come in tomorrow, make sure that you have gone through everything that we have covered in lesson 1 and lesson 2, such that you can be the words that the professor will be using are a bit familiar to you. Otherwise, when you don't understand those words, it may be a bit, you may feel as if you have not understood the lesson. So let us go through the lecture notes that the professor is giving us, such that when we come tomorrow, we can be able to fit into the lesson 3, which is on wisdom. I want to thank everyone that has been able to join this call. Thank you so much. Thank you so much, all the teachers. But most importantly, I want also to thank the professor for sparing time to share with us his wisdom and also to spearhead this session on coding in agriculture. Thank you so much, Professor, and thank you so much, everyone. Let me wish you.
Thank you much, Stephen, and everybody. God bless.
Okay, God bless you too. Have a nice afternoon, everyone. Bye.